Hello guys, this is Subir Kumar Saukara. Today we are here to discuss a lead code problem of next grid element. Okay, basically the problem is all about finding the next grid element for the corresponding array. The core idea is this, and this is a variation of a stack problem where we have to find the next grid element. Let's get into the problem description. The basic, I will give the outer summary of this description. It is that nothing that there will be you will be given with two arrays num1, nums1 and nums2, where you have to find the corresponding next greater element of the element in number one, which is existing in num2. For example, if you want to find the corresponding next greater element of 4, you have to search this 4 in num2 and you have to find the next greater of element 4 in nums2. Okay, for example, let us take this num1. For example, this 4, right? First element 4 in nums1, you will find the where it is existing. Okay, in nums2 it is existing on the third element. Okay, for that, right, you have to find the next greater element. The next greater element corresponding to the 4 is nothing, so -1. So that's why the answer is -1. uh, and for this one, right, you will for this one you will find the next corresponding element in nums2. That one is 1, and you will find the next greater element for this one, right? The next greater element is 3, so the answer is 3. Similarly it works. So the basic math problem of this, you have to find the next corresponding element for the num2. If you find it right, automatically it is easy to find the element if this element present in this num2 or right, and you will display the corresponding element. Okay, so the basic core idea is to you have to find the next great element of all the elements in num2. For that, what we'll do is that for I think you got the idea, right? For finding the next great element for this, right? Let's take the array this one. For this, right? For one, right, the next corresponding element, next greater element is 7, right? For 7, right, the next greater element is not 4, not 2, not 6, not 3, 3. So the answer is 8. For example, this is how it works. Okay, let us dive into the solution. This is what the solution I wrote. You can see the submissions also. Today only I submitted an hour ago. Let us dive into the solution. Right. For this, right, I had a there will be a function next great element. It will be giving with the two parameters num1 and num2, two integer arrays. Right. I will take first the approach is that we have to find the next greater element for the nums2. So I will take an uh, empty array which is of length nums2. Okay, and what I will do is I will fill every element that extra element array, right, with -1. Further, this is what I wrote. See here. First of all, I take an extra array, auxiliary array of length nums2, and I filled with -1. This is what the first thing. Then I instantiated the stack from collection. And for that, right, then I started finding the corresponding elements for each elements in nums2. For that, I am writing the loop. I started a loop for 1, 3, 4, 2. Okay. For that, right, what I have did is for each element in nums2, I check I will check the stack. If there is an element, if the stack is not empty and the number which I am taking, right, for example, first I am talking about 1. This 1 is not greater than, if the 1 is greater than the 2, if this 1 is greater than the nums2 peak element, sorry, then we will remove it and replace with the okay. Let's try run with an example. For example, let's go. What I did is let me take an empty stack. Okay, this is an empty stack. First, I will encounter 1. This is what, and I want to find the next greater element. In the stack, right, I will store the indexes, not the element values. It is the most important notations you have to remember it. Okay, this is a star note of this problem. you have to store the indexes of the element, not the element value. Why? Because we will get to know that. Okay, let us do run this example. For this one, right, I will check if the stack is empty. Okay, now for this one I will check if the stack is empty, or um, uh, let's go, let us copy this case. Okay, let us copy this one, and let us see, and let us go with it. This is what the code is, right? Okay, let us see. So for this, right, we have to see that, see, for every element in num2, right, this is num2, we will check if for the first element, right, 1, we will check if the stack is empty or not. Okay, let us check if the stack is empty or not. If the stack is empty, if the stack is empty, then accelerator sign means opposite, false. So the it won't go to the this loop, and it will come st dot push. I am pushing the index, so I am pushing the index of the 1. What is the index of the 1? 0. Okay, first I push. Okay, na? Then coming to the next one. Okay, right? The until now the auxiliary array is all -1 only. Let us see. Let us come to the second example. This is 7. We'll check if the stack is empty or not. The stack is not empty. We are having any value, and we'll check that num2, the value which is now, right, 7 is greater than the topmost element in 0. So what is the element index 0? 0 is 7. 1. So 7 is greater than 1. So it's true. What we will do is, if both the, until we remove all the elements from this stack, we will we will empty the stack, and we will update the auxiliary, that array, and we will put the latest element. If see for 7, right, for 7 it is greater, so it's true. Let us see. Let's pop. I will do st dot pop and auxiliary. I will, for that auxiliary, right, there will be an array, auxiliary array, right. In that zero index of that auxiliary array, I will put the greatest element for this. For example, if the greatest element at the index is nums2 of I is 7. So we are, because here, right. So I will update with the 7. Okay. And that now, yeah, as this array is empty, then we can go for, we can push, what do you call this, is array. So we will push again what, index of I. So 1 I will be pushing. Okay. So 1 I will be pushing. For 1, right, let's just check it. For the next loop, right, 7. We'll come to 7, we push it, right, it is got pushed. Next we'll come to 4. As you see that this stack is not empty, and 4 is greater than peak element 7. No, it is false. So you'll directly push into what? You'll push the index of 4. What is the index of 4? 2. Okay, no? Then you'll come to 2. Okay, 2 is, you will check. Stack is empty, no, and true. So you will check here, if num of 2, this 2 is greater than the topmost element in P. Okay, what is the topmost index in the 4? 2 is not greater than 4. So false. So you will again push this 2 also. Okay, you will push index. So you will push the index of 2, that is 3. Okay, you push. Now we encounter 6. You will check 6 is greater than third element. What is the third element? 2. Okay. Now it is 6 is there, so it is true. So you will pop out the index, and in the index place of auxiliary verb, for example, 3, right? 1, 2, 3. This is the third position. In this, you will insert the what is the element which you encountered now. What is it? 6 we encountered. So in this element, we will encounter 6. See, for this purpose only, we will use the this one, so that you can update at any place. based on the index number. If you insert the value directly into it, you cannot insert anything. But when you can directly update the value, but you cannot insert it right in the auxiliary value. So you cannot keep the track of it and you cannot fill every element. Now 3 is removed, okay? Okay, then it is if stack is empty, yeah, it is not empty. And num of I is greater than C. If num of 2, num of 2 is 6. 6 is greater than 4. It is index of 2 is equal 4, right? That's true. Then what will it? You will pop that 2 also at index auxiliary of 2, 1, 2. You will add that matching value. So you'll update 6. Similarly, you will come at stack is not empty and num of 2 is also greater than nums of peak. So let us check. 6 is greater than what? 6 is greater than num of I. What do we call? So it's 1. True. 6 is greater than 2, right? Nums of 2 peak 1, 1, 1, 7. False. So 6 is not greater than false. So you will push. You will push what? You will remove this and you will push also what? Now array contains only what? Only index 6. What is the index? 1, 2, 3, 4. 4 it will be. Okay. Then what? We'll go to the next element. 4 is coming now 3. 3 is greater than num of 5. 3 is greater than the peak element. What? 6. False. So it will add what? You'll add the index to the stack. What is the index? 5. Similarly, you will come to the next element 8. 8 is greater than the peak element 3. So you will update the 3. So you'll update 8 and you will remove this 5 and you will update 4 also with 8 and you will remove this 4. As it is empty, you will come to the push and you will push the next element. What you will push in the stack now? The new stack contains what? 8. You will push 8. Okay. And now the chance come to 9. 9 is greater than the element topmost element, not empty. So you will pop out the 8. Pop, you don't insert 8, you will insert the index, right? Index of 8 is 1, 2, 3, 4, 5, 6. You will enter 6. So you will pop out the index value 6 and you will update with the 9. And there will be remaining element, right? As it is an auxiliary verb, right? It is already inserted with mm, -1. So last element it will be already -1. So this is the updated array, right? This is the solution. If you get the array right, 7, 6, 6, 8, 8, 9, 1, then you can easily update the remaining. For example, we got this array, auxiliary array. Okay, let's go to the problem. Until now, you'll get the auxiliary array. This is the auxiliary array for this num2. Okay, this is I outputted it. By using this, right, what I did, then I printed it. The auxiliary, you can see the print. For example, to showcase you, I printed it. Then I created a hash map, and I stored hash map, and I stored every element of num2 and corresponding next greater element in that. So I stored it in the hash map so that I can retrieve easily. So for example, here only for 1 I stored 7, for 7 I stored 8, for 4 I stored 6. You see, there may be duplicate elements, but the problem constraint says that all the element digits in num1 and num2 are unique. So that's when I got the idea to use the hash map. That's the critical issue. Okay. And so after that I'm storing in hash map, right? We can retrieve any element from the hash map within a constant time. So that's when I stored in hash map. Then after ASMAPRED, then I iterated over these elements and directly updated the num1 array only. Okay, num1 array for corresponding, I run a loop over the num1 and I found that I updated the element which I found at 4. So let's get the hash map value. By using hash map, right, I get the value corresponding value of 4. What is the next greater element of 4? And I updated in the same place. In place only I did. For 4, I wrote -1. For 3 -3, see this is how it works. And if you run, the problem solution works. Yeah, for all 3 cases found, if I submit also, it is getting submitted. Yeah, it's because I used it for this one. Hmm. print statements. That's not okay. Yeah, this is what it is. Thank you so much. If you like this video, please give a suggestion in the comment box. Thank you.